Have you ever wondered what's actually keeping your most vital organs safe right now? Well, welcome to this explainer on thorax anatomy. Whether you're a medical student, a healthcare pro, or just someone, fascinated by how the human body works, understanding ribcage anatomy is absolutely foundational. In the next few minutes, we're going to break down the precise bones, joints, and hidden networks that literally keep you alive. Let's jump right in.
So let's start with a crucial question to get us thinking. We all know we have ribs, right? But what exactly are they protecting? And why in the world do medical professionals classify some of these bones as false or even floating? Well, as you'll see, the anatomy of your chest is way more than just a simple box of bones.
Okay, let's dive into this. The thoracic cage is essentially this incredible domed bird cage made of bone and muscle. It's perfectly designed to house and protect your heart and lungs. It forms the upper part of your trunk, right between your neck and your abdomen. But, it's not just a static shield. This skeletal framework provides a massive network of attachment sites for the muscles of your neck, back, abdomen, and upper arms. It's a highly dynamic, moving structure. It's like a complex pump that allows you to breathe every single second of the day.
Section 1. The thoracic cage, overview and boundaries. To really grasp ribcage anatomy, we have to look at its three main boundaries. Think of the cage like a highly secure vault. Up front, it's formed anteriorly by the sternum. That's your heavy front door. Laterally, or on the sides, you've got 12 pairs of ribs acting as curved protective bars. And posteriorly, in the back, the 12 thoracic vertebrae provide this solid foundational pillar. Together, they create the ultimate defensive shield for your vital organs.
Section 2. The sternum, anatomy explained.
Moving to the front of the chest, let's examine our anchor point. This perfectly illustrates the three parts of the sternum. You've got the manubrium up at the top, the long body right in the middle, and that little pointed xiphoid process at the bottom. Together, they link your shoulder girdle to the thorax. The manubrium is the thickest, most massive part, connecting directly to your collarbones. Then, that long body in the middle has these distinct notches on the sides where the ribs literally lock into place. Oh, and here's a surprising fact for you. Up to 10% of the population actually has a small, totally harmless opening right in the middle of their sternal body, called a sternal foramen. Crazy, right?
Section 3. Three types of ribs: true, false, and floating.
Now, humans typically have 12 pairs of ribs forming the sidewalls of our cage, but this part is actually really often misunderstood. Ribs are categorized based on exactly how they connect to the sternum in the front. We actually have three different types. True ribs are pairs 1 through 7, false ribs are pairs 8 through 10, and floating ribs are those 11th and 12th pairs down at the bottom.
If you look closely here, notice how the true ribs have their very own costal cartilage connecting directly to the sternum. They're like individual, sturdy bridges. The false ribs, though, they don't get their own direct path. Instead, they kind of piggyback on the cartilage of the 7th rib right above them to reach the sternum. And those floating ribs, well, they don't connect to the front at all. Their cartilage simply ends within your abdominal muscles. That's what gives you so much flexibility right at the base of your torso.
Section 4. Rib classification: typical versus atypical.
So beyond how they connect in the front, ribs are anatomically classified by their specific architecture. The crucial point to remember is that typical ribs follow a standard blueprint, whereas atypical ribs have highly specialized shapes for very specific jobs. Ribs 3 through 9 are your typical ribs. They all feature a wedge-shaped head that connects to the spine, a short neck, a small bump called a tubercle that acts as a joint surface, and a long curved body. But ribs 1, 2, 11, and 12, they break these rules entirely.
Now, here's where it gets really interesting. Look at the typical rib on the left and compare it to the first rib on the right. That first rib is totally flattened, horizontal, and has these specialized grooves for the subclavian artery and vein. Because it sits completely flat at the very top of your chest, it acts almost like a protective roof over the top of your lung. And those unique grooves, they create a safe, sheltered pathway for the major blood vessels traveling all the way out to your arms.
The second rib is also atypical. It's much longer than the first one, and it features a rough patch right on it called the serratus anterior tuberosity. This spot is absolutely crucial as a muscle attachment site. Unlike the typical ribs below it, the second rib needs this specialized, roughened area to anchor the serratus anterior muscle. That's a powerful muscle that basically helps you rotate your shoulder blade and lift your arms above your head. Then we have the 11th and 12th ribs. These guys are exceptionally simple.
They completely lack the standard necks and tubercles that we just saw on the typical ribs. Because they're floating and don't wrap around to connect with the sternum in the front, their bodies are short, narrow, and kind of pointed at the ends. They just have a single articular facet on their head to connect to the spine in the back, making them literally the most stripped-down, basic ribs in the whole thorax.
Section 5. The thoracic vertebrae, the posterior wall.
All right, so we've covered the front and the sides. Now let's look at the 12 thoracic vertebrae that hold the whole thing together in the back. The absolute defining feature of these vertebrae is the presence of costal facets. These are the exact articulation points where the heads of the ribs lock right into the spine. Think of these facets as custom-made sockets. The ribs don't just lean against the spine, they form these complex articulating joints that allow your entire chest cage to expand and contract smoothly with every single breath you take. Okay, so we have our protective, bony cage established. But what about the sensory network that lives inside it? I mean, bones alone can't function without a supply line of blood and a communication network of nerves telling the muscles exactly when to move, right? So how do all these bones actually communicate with the brain?
Section 6. Intercostal spaces, nerves and vessels.
The gaps between your ribs are known as intercostal spaces, and far from being just empty space, these gaps are completely packed with 3 layers of intercostal muscles that actively pull your ribs up and down while you breathe. If you look closely inside the costal groove of a typical rib, you're going to find the VAN structure. That stands for vein, artery, and nerve, arranged super neatly from top to bottom. Tucked safely along the inside, bottom edge of the rib, this VAN order is always consistent. The vein sits highest, the artery is right in the middle, and the nerve is at the bottom. But here is an absolutely critical clinical detail. While the vein and artery get sheltered by the overhanging bone of the rib, the intercostal nerve hangs lowest and is often completely unprotected. This makes it way more vulnerable to irritation or injury.
Now, what's really fascinating here is seeing how these intercostal nerves branch out segmentally from your spine. They supply both motor function to the muscles and sensory feedback directly to your brain. These nerves carry the signals that contract your chest muscles so you can actually breathe, and they send sensory info from the skin of your chest, your ribs, and even the lining of your lungs straight back to your brain. It's this brilliant, highly organized, closed-loop network.
So to summarize our macro to micro journey through thorax anatomy, remember these 3 main takeaways. First, the thorax acts as a highly protective and incredibly dynamic birdcage. Second, the sternum acts as the central anchor for your true ribs via those costal cartilage bridges. And third, those spaces between the ribs, they aren't empty at all. They're vital highways housing the crucial VAN structure, the vein, artery, and nerve.
If you found this visual breakdown helpful, make sure to subscribe for more simple medical explanations. And hey, let me know in the comments, which part of the ribcage surprised you the most today? Was it the bizarre horizontal first rib? Or maybe the fact that the lowest intercostal nerve isn't fully protected by the bone? Let's keep the conversation going below. Thanks so much for learning with me today, and as always, stay curious.